Stop wasting your money. The 7 supplements that are not delivering. What you think every year, the global dietary supplement industry generates hundreds of billions of dollars in revenue. Millions of people wake up every morning, reach into their medicine cabinets, and dutifully swallow a collection of pills, capsules, and powders with the sincere belief that they are investing in their health. The supplement industry has become one of the most profitable sectors in the entire consumer market, fueled by a combination of genuine health consciousness, clever marketing, and the deeply human desire to do something concrete and tangible to protect our well-being. But here is the uncomfortable truth that the supplement industry has little financial incentive to advertise. A significant number of the most popular and most widely purchased supplements are either providing negligible benefit, delivering nutrients in forms that the body cannot effectively use, or in some cases, actively working against the health outcomes their buyers are trying to achieve. Today we are going to have an honest, evidence-based conversation about 7 of the most commonly purchased supplements that deserve serious scrutiny. This is not an argument against supplements as a category. Some supplements, taken in the right forms and at scientifically appropriate doses, can make a meaningful and measurable difference to health outcomes. But distinguishing between the genuinely useful and the well-marketed but largely ineffective requires the kind of critical analysis that the supplement industry rarely encourages its customers to apply. Let us begin. Supplement 1. Calcium supplements. Calcium supplements represent one of the most striking examples of a deeply entrenched health recommendation that the underlying evidence simply does not support. For decades, the medical establishment, dairy industry marketing campaigns, and popular health media have delivered a consistent and largely unquestioned message. Take calcium supplements to build strong bones, prevent osteoporosis, and protect yourself from the fractures and mobility limitations that can come with aging. This message has been so effective and so pervasive that questioning it feels almost counterintuitive. Yet the scientific evidence tells a substantially different and more complicated story. While calcium is unquestionably an essential component of bone tissue, the assumption that supplementing with isolated calcium will cause that calcium to travel to your bones and strengthen them is not well supported by the research. Multiple large-scale studies examining the effects of calcium supplementation on bone density and fracture rates have produced results that range from unimpressive to genuinely concerning. The concern is this: calcium taken in supplement form does not come with the biological machinery that tells it where to go once it enters the bloodstream. Without the cofactors and dietary context that guide calcium into bone tissue, supplemental calcium has a troubling tendency to deposit in places where you do not want it, most significantly in the walls of arteries and blood vessels. Arterial calcification is a key driver of cardiovascular disease, one of the leading causes of death in the modern world. Several studies have found associations between calcium supplementation and increased risk of cardiovascular events, a finding that has deeply troubled researchers who expected to see only beneficial effects. The contrast with food-based calcium is illuminating. When calcium is consumed as part of whole foods, it arrives alongside the proteins, vitamins, and other compounds that facilitate its proper absorption, transport, and deposition into bone tissue. Dark leafy green vegetables are exceptional sources of bioavailable calcium. Animal proteins, including fish, provide meaningful calcium in a form that the body handles well. And perhaps most elegantly, small fish consumed with their bones intact, such as sardines and anchovies, deliver calcium in precisely the biological matrix in which nature packaged it. It is worth pausing to consider the dietary pattern of some of the longest-lived populations ever studied. The Acciaroli community in southern Italy, a region that has produced a remarkable concentration of centenarians, subsists on a diet rich in small fish, particularly anchovies, consumed whole with their tiny calcium-rich bones. These individuals are not taking calcium supplements. They are getting their calcium from food in a form their bodies evolved to handle, alongside the vitamins and proteins that ensure it ends up exactly where it belongs. If you are concerned about bone health and feel compelled to spend money on calcium, the most evidence-aligned recommendation is to redirect that budget toward quality sardines, anchovies, or other small whole fish. Increase your consumption of dark leafy greens, and ensure adequate intake of vitamin D and vitamin K2, the vitamins that actually regulate where calcium goes once it enters your body. These latter two nutrients are the genuine heroes of bone health and cardiovascular protection, and we will touch on vitamin D shortly. Supplement 2. Standard multivitamins. Multivitamins have been a staple of the supplement market for nearly a century, and their ubiquity has lent them an air of unquestionable legitimacy. Surely something this universally recommended, this widely available, and this long established must be delivering meaningful health benefits. The reality, unfortunately, is more nuanced, and understanding it requires a brief history lesson about where the dosing recommendations in most multivitamins actually come from. The nutritional reference values that underpin most multivitamin formulations trace their origins back to studies conducted in the 1920s, when the American federal government was attempting to establish the minimum daily requirements for various vitamins and minerals. The methodology was straightforward but extremely limited. A small group of apparently healthy college students in New York City had their dietary intake and blood markers assessed, and the nutrient levels associated with their baseline health were used as the foundation for what became the minimum daily requirement recommendations. There are several profound limitations to this approach. First, the sample size was tiny and geographically and demographically narrow. Second, and most critically, the goal was explicitly to identify the bare minimum intake needed to avoid deficiency diseases like scurvy, pellagra, and beriberi, conditions caused by severe and prolonged nutritional deprivation. The minimum daily requirement was never designed to represent the optimal intake for robust health, disease prevention, longevity, or peak physiological function. It was designed to define the floor below which catastrophic deficiency disease would occur, not the ceiling of what the body needs to thrive. The distance between these two targets, the floor of deficiency prevention and the ceiling of optimal health, is vast. And for many nutrients, it is so large as to render standard multivitamin dosing essentially irrelevant to any meaningful health outcome. Vitamin D provides perhaps the most striking illustration of this problem. The minimum daily requirement for vitamin D, as established by these decades-old recommendations and reflected in most multivitamin formulations, sits at approximately 400 international units per day. Research conducted at the University of California, San Diego, however, suggests that the minimum daily intake needed for meaningful cancer prevention alone is approximately 9,600 international units per day, a figure that is 24 times higher than what most multivitamins provide. This is not a marginal discrepancy. It is a difference of such magnitude that it fundamentally undermines the premise that taking a standard multivitamin containing 400 IU of vitamin D addresses any meaningful nutritional need. The evidence on vitamin D and brain health is equally compelling and equally distant from minimum daily requirement territory. Research consistently demonstrates that higher circulating vitamin D levels in the brain are associated with better neuronal function, sharper cognitive performance, and reduced risk of neurodegenerative conditions. The neurological benefits of vitamin D appear to require blood levels that are achievable only with supplementation substantially above what any standard multivitamin provides. Approximately 80% of Americans are estimated to be deficient in vitamin D by any clinically meaningful standard, and similar deficiency rates are documented across most of the developed world, particularly in populations living at higher latitudes where sunlight exposure is limited for significant portions of the year. A multivitamin containing 400 IU of vitamin D is not going to meaningfully address this widespread deficiency. The broader problem with multivitamins is the one-size-fits-all approach to nutrition. Human beings are biochemically diverse. Different individuals have different genetic predispositions, different baseline nutrient levels, different absorption efficiencies, and different physiological requirements. A formulation designed to provide a middling dose of many nutrients to a hypothetical average person is almost by definition poorly matched to the actual needs of any specific individual. The money spent on a generic multivitamin would almost invariably produce better health outcomes if redirected toward targeted testing of actual nutrient deficiencies and supplementation of the specific nutrients that a given individual genuinely needs at doses that are therapeutically relevant. Supplement 3. Standard vitamin C. Tablets taken. Once daily. Vitamin C is unquestionably one of the most important nutrients for human health, and unlike some other supplements, the case for supplementing with it is genuinely strong. The complication lies not in whether to supplement, but in how to do so effectively, and most people are approaching this in a way that delivers far less benefit than they believe. To understand why, it helps to appreciate the extraordinary evolutionary story behind human vitamin C requirements. Most animals on Earth manufacture their own vitamin C internally through a 5-step enzymatic process that converts glucose into ascorbic acid. Humans, along with other great apes and guinea pigs, have lost the ability to perform this synthesis. We lack a functional version of the 5th enzyme in this pathway. The prevailing evolutionary hypothesis is that our ancestors lost this gene because they lived in tropical environments with year-round access to vitamin C-rich plant foods, making internal synthesis metabolically unnecessary. In the context of our evolutionary past, this was not a problem. In the context of modern diets that often fall far short of providing continuous adequate vitamin C, it has become a significant vulnerability. The implications of this genetic reality are illustrated vividly by a revealing experiment. Rats were genetically engineered to carry the same non-functional 5th gene that humans carry, making them unable to synthesize vitamin C internally. These rats lived approximately 50% shorter lives than normal rats who retained the ability to manufacture their own vitamin C. But when vitamin C was continuously provided in their drinking water, these genetically compromised rats lived exactly as long as their vitamin C-producing counterparts. The lesson is clear and important. Continuous, reliable access to vitamin C is not a luxury for humans. It is a fundamental biological requirement with direct implications for lifespan and health span. Now, here is where most people go wrong. Vitamin C is a water-soluble vitamin, which means the body cannot store it in any meaningful quantity. When you swallow a standard vitamin C tablet, the vitamin C it provides is absorbed, circulates in the bloodstream for approximately 2 to 4 hours, and is then excreted through the urine. If you take a single vitamin C tablet once per day, you are providing your body with a brief pulse of vitamin C availability, followed by a much longer period with little or none available. This is not adequate to meet the continuous need that our evolutionary biology requires. The solution is straightforward once the problem is understood. Either use a timed-release vitamin C formulation that extends the release of the nutrient over a longer period, maintaining more consistent blood levels throughout the day, or distribute your vitamin C intake across multiple smaller doses taken at intervals throughout the day. Taking 500 milligrams 4 times daily provides dramatically more continuous coverage than taking 2,000 milligrams once, and provides the body with the sustained availability that matches its ongoing requirements. 1,000 milligrams of timed-release vitamin C taken twice daily represents another practical approach that most people can maintain consistently. The key principle is continuity of availability. Vitamin C that is present in your body for 2 hours and then absent for 22 is not serving the same biological function as vitamin C that maintains a consistent circulating presence throughout the entire day and night. Supplement 4. Ketone drinks. The ketone supplement market has exploded in recent years, riding the wave of popular interest in ketogenic diets and the growing scientific understanding of ketones as a valuable alternative fuel source for the brain and body. Exogenous ketone products, drinks and shots that claim to elevate blood ketone levels directly have attracted considerable attention and considerable marketing budgets. They have also attracted considerable price tags. The fundamental problem with ketone drinks is threefold. First, they taste, by almost universal consensus among those who have tried them, genuinely terrible. The combination of salts and ketone esters that these products contain creates a flavor profile that most people find deeply unpleasant and difficult to consume consistently. Second, they are expensive, often dramatically so, placing them out of reach as a practical daily supplement for most people. Third, and most importantly, there is a far simpler, far cheaper, and equally effective way to achieve the same outcome. MCT oil, which stands for medium-chain triglyceride oil, is a fat derived primarily from coconut oil that is metabolized through a unique pathway in the body, Unlike long-chain fatty acids, which require processing by the lymphatic system before entering general circulation, medium-chain triglycerides are transported directly to the liver, where they are rapidly converted into ketones. A single tablespoon of MCT oil reliably raises blood ketone levels, delivers the cognitive and metabolic benefits associated with elevated ketones, and does so at a fraction of the cost of commercial ketone drinks. MCT oil is widely available, including in large warehouse retail stores, is relatively flavorless and odorless in its refined form, and can be easily added to coffee, smoothies, salad dressings, or consumed directly. If the goal is elevated ketone availability for brain fuel, metabolic support, or any of the other documented benefits of ketosis, MCT oil achieves this goal more economically, more palatably, and with equal physiological effect. Spending significantly more money on commercial ketone drinks in pursuit of the same outcome is a choice that the evidence does not support. Supplement 5. Low-quality probiotics. The probiotic supplement market is one of the most intriguing and simultaneously one of the most problematic areas in consumer health supplementation. The underlying science of the gut microbiome is genuinely exciting and rapidly evolving. Research continues to reveal the extraordinary importance of a diverse and thriving gut bacterial community for virtually every aspect of human health, from immune function and metabolic efficiency to mood, cognitive function, and even personality. The case for supporting gut microbiome health through dietary and supplemental means is strong. The problem is that the vast majority of commercial probiotic supplements on store shelves are failing to deliver their bacterial cargo to the destination where it needs to arrive. To have any beneficial effect, probiotic bacteria must survive the transit through the highly acidic environment of the stomach, which exists precisely to destroy ingested microorganisms and reach the intestines alive and in sufficient numbers to have a meaningful impact. Most standard probiotic capsules and tablets provide no particular protection against gastric acid. The bacteria they contain, regardless of how impressive the colony-forming unit count on the label appears, are largely destroyed before they ever reach the intestine, where they need to colonize. Two categories of probiotic products are significantly more likely to survive gastric transit and deliver live bacteria to the intestine. The first is spore-forming probiotics, in which the bacteria are in a dormant spore form that is highly resistant to acid, heat, and other environmental stressors. These spores survive stomach acid and germinate into active bacteria once they reach the more hospitable environment of the intestine. The second category consists of probiotics with enteric coating, a specialized coating applied to capsules that resist dissolution in the acidic stomach environment, but dissolves readily in the more neutral pH of the intestine, releasing its contents precisely where they need to go. Even when you select a probiotic that successfully delivers live bacteria to the gut, there is a second important reality to understand. The bacteria contained in commercial probiotics are almost without exception not native to the human gut. They are selected and grown in laboratory conditions, and while they may provide temporary beneficial effects during their residence in the intestine, they do not permanently establish themselves as part of the native gut microbiome. They pass through over a period of weeks and then disappear. This means that any benefit derived from probiotic supplementation requires ongoing continuous use rather than a single course, and it also means that the most powerful long-term strategy for gut microbiome health is not supplementation, but diet. Specifically, the provision of abundant and diverse prebiotic fibers from whole plant foods that feed and sustain the native bacterial populations that genuinely do make the gut their permanent home. Supplement 6. Standard vitamin E supplements. Vitamin E is a nutrient with a genuinely important role in human health, serving as a fat-soluble antioxidant that protects cell membranes from oxidative damage and supports immune function, among other roles. The problem with vitamin E supplements is not with the nutrient itself, but with the profound mismatch between what most vitamin E supplements actually contain and what the body actually needs and uses. Vitamin E is not a single compound. It is a family of 8 structurally related molecules divided into 2 main groups, tocopherols and tocotrienols. Each group contains 4 members designated as alpha, beta, gamma, and delta. These 8 compounds have different biological activities, different tissue distributions, and different health effects. They are not interchangeable, and the relationships between them are complex and sometimes competitive. The vast majority of vitamin E supplements on the market, including virtually all multivitamins that include vitamin E, contain primarily or exclusively alpha-tocopherol, often in a synthetic form. Alpha-tocopherol is the form of vitamin E that the body preferentially retains in circulation, and that was historically assumed to be the most biologically important. However, more recent research has revealed that other forms of vitamin E, particularly gamma-tocopherol and the tocotrienols, have important biological activities that alpha-tocopherol does not replicate, and in some cases, actively suppresses. When you consume a supplement containing predominantly alpha-tocopherol, elevated alpha-tocopherol levels in the blood actually displace and reduce the circulating levels of gamma-tocopherol and tocotrienols. Since gamma-tocopherol has particular importance for neutralizing certain reactive nitrogen species that alpha-tocopherol cannot address, taking a standard vitamin E supplement can paradoxically reduce one aspect of your antioxidant protection while seeming to increase another. The benefits of certain forms cancel out the benefits of others, leaving the net effect substantially less impressive than the marketing suggests and potentially counterproductive in ways that are not immediately obvious. If you have a genuine need for vitamin E supplementation, seeking out a product that provides a full spectrum of tocopherols and tocotrienols in appropriate proportions is essential. This type of product is more expensive and harder to find than standard alpha-tocopherol supplements, but it is the only formulation that accurately reflects how vitamin E actually functions in biological systems. Supplement 7. Iron supplements. Iron supplementation occupies a unique and particularly important position on this list because it is not merely ineffective for most people who take it. For many adults, particularly men and postmenopausal women, regularly consuming supplemental iron can actively accelerate biological aging and increase the risk of serious chronic disease. This claim runs counter to decades of nutritional messaging that has associated iron with energy, vitality, and strength. And for specific populations with genuine iron deficiency, supplementation is indeed sometimes necessary and beneficial. But the critical distinction between iron deficiency and normal iron status is one that is frequently overlooked in the rush to supplement. The aging mechanism involves what biologists describe as rusting. Iron is a highly reactive metal that participates in a class of chemical reactions called Fenton reactions, which generate extremely reactive and damaging free radical species. When iron accumulates in tissues, it promotes oxidative damage to proteins, lipids, and DNA throughout the body, a process that is functionally analogous to the rusting of metal. This iron-driven oxidative damage is a meaningful contributor to the cellular deterioration we experience as aging. The epidemiological evidence on iron accumulation and longevity is striking. Studies examining blood donation patterns and life expectancy have found that regular blood donors live meaningfully longer on average than non-donors, with some research suggesting a difference of approximately 7 years in life expectancy. This observation is consistent with the hypothesis that periodic removal of iron through blood donation prevents the accumulation of excess iron and its associated oxidative damage. The comparison between male and female longevity provides another piece of supporting evidence. Women live on average approximately 7 years longer than men across most populations worldwide. While multiple factors contribute to this difference, one hypothesis that merits serious consideration is that women of reproductive age donate a meaningful amount of blood through menstruation each month for approximately half of their adult lives, continuously preventing iron from accumulating to the levels typically seen in men of the same age. There are genuine circumstances in which iron supplementation is appropriate and necessary. Women with particularly heavy menstrual cycles may develop true iron deficiency anemia and require temporary supplementation to restore adequate iron stores. But for men and for postmenopausal women, iron deficiency is actually unusual and warrants medical investigation rather than reflexive supplementation, because blood loss is the primary physiological mechanism through which iron is depleted, and unexplained blood loss in older adults requires diagnosis rather than dietary correction. a critical framework for evaluating all supplement research. Before closing, it is worth addressing a broader pattern in supplement research that is important for anyone trying to make sense of the frequently conflicting studies and headlines that appear in the health media. Large population studies periodically appear in prestigious medical journals, concluding that various supplements provide no benefit and represent a waste of money. These studies are sometimes used to argue against supplementation broadly, but these studies almost invariably share a critical methodological limitation. They examine supplements administered at doses corresponding to the government-established recommended daily allowances, the same minimum daily requirement figures we discussed earlier that were designed to prevent catastrophic deficiency disease rather than to optimize health. Finding that a dose of vitamin D calibrated to prevent rickets does not meaningfully reduce cancer risk or improve cognitive function is not a surprising result. It is exactly what you would predict if you understood the fundamental inadequacy of the dose being tested. The lesson is not that supplements are ineffective. It is that dose matters enormously, that the dose matters in a way that most widely publicized studies are not designed to capture, and that evaluating any supplement's potential value requires knowing both the right form of that supplement and the dose range within which its benefits have actually been demonstrated. When you encounter a study claiming that a particular supplement is useless, your first critical question should always be, what dose were they testing, and how does that compare to the dose range that the relevant biology suggests would be needed to produce a meaningful effect? Conclusion: spend smarter, not more. The supplement industry thrives on the aspiration for better health and the hope that a capsule or powder can bridge the gap between the diet we actually eat and the nutrition our bodies genuinely need. Sometimes that aspiration is well-founded. There are supplements that, taken in the right forms and at appropriate doses, deliver real and measurable benefits. Optimized vitamin D supplementation, continuous vitamin C availability, targeted micronutrient repletion based on actual testing, and carefully selected probiotics with genuine delivery mechanisms can all play a meaningful role in a thoughtfully constructed health strategy. But spending money on calcium supplements that may calcify your arteries rather than strengthen your bones, on multivitamins dosed at levels designed to prevent 19th century deficiency diseases rather than support 21st century health optimization on standard vitamin E that actively reduces the circulating levels of the very vitamin E forms you most need, on ketone drinks when a tablespoon of MCT oil achieves the same result at a fraction of the cost, on probiotics that are destroyed by stomach acid before they reach your gut, or on iron supplements that accelerate the very oxidative aging process you are trying to prevent is not an investment in health. It is an expensive exercise in misplaced optimism. The most valuable thing you can do with this information is not to abandon supplements entirely, but to apply the same critical intelligence to your supplement choices that you would ideally apply to every other health decision. Ask what the active compound actually is and whether the form in the product is biologically usable. Ask what the research-supported dose range is and whether the product provides it. Ask whether your money would produce better health outcomes if redirected toward food, testing, or a different and better formulated product. Your health deserves better than the minimum daily requirement. Make sure the supplements you choose reflect that.